Welcome back. In this video we're back on the Quadratrac low range unit. Before we start assembly, let's first talk about what I did since the last video. Basically I cleaned up everything with just solvents. Made sure there's no burrs on any of the sealing faces. I ran a tap through the threads to make sure everything was straight there. And then I added 2 1/4-inch bolts and this mounting location. I think this is used in like a Cherokee application. Anyway, it's not used for the CJ application, so in case I ever want to use it to maybe run some wires or mount something, I put a couple bolts in just to keep the threads clean, and that's it. Before we get started, also let's talk about where to get parts for these rebuilds. The closest thing you'll find to a one-stop shop is called BJ's Off-Road. It's over in Washington State. They specialize in full-size Jeeps, which came with these transfer cases, so they've done a nice job of keeping a supply of parts, and that'll actually be more important in the next video when we talk about the main case. As it turns out, they don't actually offer many parts for the low range unit, so I will, as I install the parts, show you where I found those, what the part numbers are. So from BJ's you can get a seal kit. It says, actually that's not it, they said it includes every seal for the transfer case, and it almost does, but not quite. I won't go through it because actually all these parts are essentially for the main case except for one O-ring for sealing the low range unit to the main case. So what's missing then is the O-ring that seals the shift lever, which is what I was having trouble with leaking. It goes here. So that's not in the kit. Also the gasket for sealing the power takeoff cover is not in the kit. And also the shaft seal on the speedometer gear, which I'll get to in the next video, is not in the kit, so I found all of those elsewhere. The other seal kit that's available is called a TSK 200. You can get that on any number of transmission supply or eBay or whatever. And it has even fewer parts overall than the BJ's kit. BJ's kit has everything that this kit has, except for the cork gasket for the power takeoff cover. So I think realistically you could buy the BJ's kit and use some RTV here, and that would be just fine if you don't want to buy a whole kit just to get one cork gasket. I did just because I was curious to see what actually comes in these kits, so I can share with you guys and decide what I want to do. There's one other kit, it's called a BK1305. That comes with some bearings and some seals. I don't have one at the moment. I've heard rumors that they also come with the nylon shift fork pads for the emergency drive shifter. We'll see when it arrives, and I'll report back on that. So, all right. Most of the parts have been soaked in the transfer case fluid that this unit uses, which is you can buy from Crown Automotive. It's called TCL1. You can also make your own from 30-weight oil and friction modifier. But this is very convenient. It's always worked for me. And some people maybe report that it doesn't work too well, but I've never had a problem with it. So we're going to do that. And before I install bearings, I'd like to soak them in a little bit of fluid. Alright, first thing we'll do is install the main bearing in the back of the case where the PTO goes. So this is the old bearing. It was a Federal 1306, I believe. It's kind of worn off. But anyway, the replacement for that is a SKF Explorer 6306. There are some more options for this. This is a standard bearing size. I think I got this one from Motion Industries, but you can find them any number of places. I'll leave a link to this one, but nothing special here. You can find the replacement bearings in a number of different places. And it feels quite a bit better than the old one we took out. I'll soak this in some fluid while we get the locking rings ready. So the ring in the front of the case, or deeper into the bore in this view, should be between 0.086 and 0.088 inches. Which this one is right at 0.87 or 8. So that one could go in the front. Yeah, that one is thicker, 0.09 basically. Yeah, okay. So this one we'll install in toward the front of the case. This may actually be easier from the other side. Okay, just like that. Okay, so then the bearing goes in. This bearing doesn't have a cage or a seal, so it can go either direction, but it should basically drop in against this lock ring. And just like the old one coming out, it doesn't quite just drop in, so we need to tap it in. And there it goes. May have been just a slight burr on that edge that was preventing that. And now for the front ring, or sorry, the back ring, the next one up in the stack in this case. These were available in different thicknesses. Of course, when you take one of these apart, you just have one thickness to work with, right? So this one is nearly 0.09. The range was 0.086 to almost 0.1 inch. So there was quite a bit of variation. So let's see if the 0.09 ring will go back in. We'll go from there. Seems like it will. Okay. There's the front ring in, or the back ring in. So the service manual says to install the thickest snap ring that will see completely. And I don't think a thicker ring would work in this case. So we're probably good on that. Let's move this aside and move on to assembling some of the gear train. Alright, let's first assemble the ring gear and the ring gear plate. You'll remember that was held by a snap ring. And with all these snap rings, you want to make sure they're actually all the way into the groove, like that. Then next comes the reduction collar plate hub. Like that, and then that's secured with a snap ring on the front. Alright, for that we'll use our snap ring pliers. This is the original snap ring. Then again, make sure it snaps. Then again, make sure it actually snaps into the groove. Like that. Alright, that's the ring gear essentially assembled. Next we're going back to the case and then place the locking ring, the holding ring, and remember this has feet on the back. They need to line up with the holes in the case, and then there's a hole for the spring pin that aligns to the shift fork, and that needs to align to the boss here in the case where that pin goes. And then that's held into the case by a snap ring. And in this case you want to make sure the snap ring, the open part of the snap ring doesn't interfere with where all the shifter mechanism goes here. So put the open side toward that. Okay, that's all snapped in. And it does not interfere with the shifter mechanism. Up next is the shift lever assembly, which is this guy. This was the one we were having trouble, the leaking O-ring. So instead of installing the O-ring first and then forcing it all the way through the case and possibly damaging the O-ring, what you can do is first go ahead and put the shift lever all the way to through the bore with the tab facing out of the larger hole here, and then you can put on your O-ring. Now, as I mentioned, no one really sells an O-ring specific for this, so I just found one that will work. So I bought these from the O-ring store. They're Buna-N or nitrile, which is good for automotive fluids, and you can see it's 7/16 by 5/8 by 3/32 cross section. And these are actually X rings instead of O rings. It just means they have an X cross section instead of round, which I don't know if we can really see that on camera. But anyway, it gives more sealing surfaces basically than an O-ring, but a regular O-ring will work. This is not necessary. And then we'll put a little bit of lubricant on the O-ring before we install it. A little O-ring grease. Then try to install. Yeah. Okay, so that's in. Let me clean up my mess, and I'll be right back. Okay, now that that's cleaned up, the next step is to press the shifter into the bore and seat that O-ring. And the trick is, in the last video, I took the pin out that holds the shifter in. I was trying to drive it the wrong direction. I don't know if you can see this, but it's actually slightly tapered. It's a taper pin, so it only comes in and out one direction. You can see that it's somewhere around 0.13 on the narrow end and about 0.16 on the longer end. And this is actually a standard part, about 1.25 inches long. So I'll leave a McMaster part number here in case you want to buy one. You can get them in steel or stainless steel. I don't have those, so I'm going to reuse the old one. And then this is the larger side of the taper hole, and this is the smaller, so the pin has to go in this way. And so what we want to do is push this in enough to get that pin to fall in. And there it is. And once that's in, just drive it on home until it feels like it's firm in the case. You can see it comes all the way through. Good to go. So hopefully that fixes my leaky O-ring problem that I've had for a while now. Okay, up next is the shift fork and shift rail. And remember, the shift rail has detent positions. So there's a spring and ball, detent ball, that goes into here to catch those grooves. So first goes in the spring. And then the shift rail has a flat on it. And you want to slide it in from the back of the case with the flat facing where the ball will be, where that spring is. So it'll help the shaft go over the ball and the spring. So like this. And then the shift fork goes in like this. And you'll notice the hole in the rail doesn't line up to the hole in the fork when the flat is toward that ball. That's all right. We'll rotate that later. So basically the shift rail is now just touching that spring. You'll not be able to see it in there, but it is basically stopped by the spring, which is convenient because then it gives you a way to drop the ball in, and it kind of rests against the rail and finds its home on the spring. Then this is a bit tricky. What I like to do is put this rail down on the bench with just a little something behind it, and so to keep it pressed up against the edge of the spring, and then from that position you can get some leverage to press with like a punch and compress the ball into the bore, and then press down on the whole case, and the shift rail will come forward over the ball. So align the ball to the top of the spring. Press it down into the bore. And then press down on the whole case, and you see now the rail has come to the punch. Remove the punch. Make sure that rail is in. You can see it's come past the tent ball now. Now it's in the first detent position. Now we want to rotate the shift rail so that the holes in the fork line up. You can use a 3/16 punch to do that. Okay, now the punch goes through both the fork and the rail. And then this is a little spring roll pin that came out. It's about 1.1 inch long. I believe it's a 3/16 roll pin, standard part. It's also available in places like McMaster-Carr. I'll leave a part number for that as well. So now we just drive the pin back where it belongs. Okay, now the fork is pinned to the rail again. You can see that the fork is also engaged to the shift lever. And see, of course, at the moment the shift rail is still free to rotate, and that's the purpose of this the pin that sits here to orient the fork in the correct direction, which we will install next. In removing the previous one, I scratched it up pretty badly. It would probably be just fine, but since this is a standard part, I decided we'd go ahead and replace it. So that's a 1/4 inch roll pin, about 2 inches long, and I'll put the McMaster part number up for that one as well. But to install, simply drop it into the hole. I'm using either a punch or a drift to drive it in. It goes in much easier than it comes out, but what you can check here is that in the most forward position, the pin is still at least somewhat in the hole in the fork. So now the shifter mechanism is essentially all back together, but we have these open bores for the shift rail, for the detent spring and ball, and of course the large cover here. So I want to clean up these surfaces a bit with some solvent, because I'm going to use a little bit of sealant. Basically, I'm going to use expansion plugs, which, you know, in a perfect world, if everything's perfectly machined, they probably don't really need sealant. But you know, this is 40-some years old. It's got some dings here and there. I think I'll put a little bit of sealant on that, and I'll show you that next. Okay, next we will seal up all the bores that are associated with the shifting mechanism. The original taper plugs that came out of the bore are made of steel. I cleaned these up and got the rust off. They are tapered with the smaller end of the taper is here on the open side of the cup, and it gets wider as it goes to this side of the cup. And I was not able to locate any of these. These are 3/4 inch. The bore measures just a touch under 3/4 of an inch. In modern taper plugs, they just taper the opposite direction. So I have an example of one here. This is brass instead of steel, and the small end of the taper that goes into the bore is this side instead of this side. So the old plug would go like this, and the new style will be cupped to the outside. But there's plenty of space for the shift rail, so I don't, you know, it's not like the shift rail comes up into the cup or anything. So I'm just going to use the modern version of this, so that these, you know, you could probably reuse these, but I'd rather them not be like, you know, this precious item that I have to hold on to. You can just buy a bag full of these for relatively cheap and get on with it. And that's there's also the 3/8 plug to plug the spring bore over here, and same story there. You can actually find in steel called reverse taper plugs, where that would be the narrow end, and it will go in like this, but in this brass one, the narrow end is the closed end, and so it will go in like that. And then like I say, they don't really need sealant if everything's all perfect, but it's a very old case, so the sealant I'm going to use is Vibra-Tite 550. It's specifically made for sealing these sort of taper plugs, freeze plugs. You can see a little picture of it right there. In order to install these plugs, I think you're supposed to actually have a special tool, but we're just going to drive them in. So for the 3/8, we'll use a 1/4 inch punch. And the only thing, the punch only needs to be small enough so that it actually hits the flat part of the inside of this cup. You don't want something that fits tightly in here that's going to get into the curved part of the cup because it needs to bend a little bit. And that was not a 1/4 inch punch, this is. So we'll do that one first. Hopefully we'll make it so that you guys can see that as well. So the instructions for this are clean, apply, and assemble. So very straightforward. So this one's a little tricky because it's so small. Doesn't need much, but it's difficult to put a small amount on this small plug. So then here's our punch. Just line it up as straight as you can. There it started. Get rid of the excess sealant so I can see where it is. You basically want it flush, it's very close. There. That's it. Installed. So same routine for the 3/4 inch plugs, except instead of I don't have a punch that is the right size, so for that I'm going to attempt a socket. And in particular, this is a 3/8 socket that's a 1/2 inch drive. Seems to be about the right size to fit in these cups. You can buy 3/4 inch plugs, and I have some, and they will go into this bore, but the bore measures are slightly under 3/4 of an inch, so these are 19 millimeter plugs. A very small difference, but I feel they drive into the bore just a little bit easier. Either one will work. And this is all of these brass plugs are standard parts. I'll show you the part numbers. I think they came from the Freeze plug factory, so I'll flash that up for the 3/8 plug and for the, in this case, the 19 millimeter plug. So same routine. Get the Vibra-Tite. And you really only mostly need it at the narrow edge. It's all gonna be forced up when you drive it in anyway. Okay. Just a little bit around the edge. And then drive it in. A pretty good start. gets a little crooked, just try to straighten it out a little bit. That may be it. Could go just a pinch further. Okay, that's it. And then same thing on the other side. And you might be tempted to drive on the outer edge of this just with a hammer, but that doesn't allow it to expand the way it should, the way it needs to. So definitely use something on the inside that'll fit to the inside diameter. Okay, there are all the taper plugs. Next we'll seal the large bore with an expansion plug. So here's the old expansion plug. It's made of steel. This one's rusty. These are available in steel and stainless steel. I believe it's a 2 3/4 inch diameter. Let's find out. Right, so 2 3/4 inch. This is standard part. I will give the McMaster-Carr number here. And again, I'll use a little Vibra-Tite to make sure this actually seals. And in this case, there's a little shoulder that this goes and fits against. And I'll put the sealant there. And then we'll strike it with a hammer and expand it into the bore. Okay, sealant's on. Drop the expansion plug into the bore. It actually fits fairly loosely in there. And then take something like a large drift. Give it a couple hard hits with a hammer. It's still loose. You want to hit it until you start to see a dimple here, otherwise it hasn't expanded. Starting to expand, but not enough yet. Okay, that has firmed up. I think it's in there tight. I'm going to hit it one more time or two. You can see we got a pretty good dimple going there. And it's tight in the case. So let's move on to the next step. So next we install the external shift lever. This is the original one made of steel. This is not necessary, of course, but I like to replace as many parts that will rust as possible. So I messed around and came up with a stainless steel reproduction of it. Now that's the one we will install. Obviously not absolutely necessary, but that's the route I decided to go. So that the two holes go toward the rear, and then we'll capture that simply with a flat washer, internal tooth lock washer, 3/8 both, and what I happen to have on hand was some stainless jam nuts. So these are 3/8 24 fine thread. And there's enough shaft there, I'll actually just go ahead and put 2. Alright, so just to refresh everyone's memory, that moves the fork forward and backward in the case. And now that we can do that, we can install the shift collar. Before I do that, I'll point out this is a shift collar I took out of the previous case, and I don't know if we can see this or not. You can probably see there are some lines here. We can focus. Yeah, there we go. It may not be obvious on camera, but those are actually cracks. They don't crack all the way through the gear or anything, but they are cracks nonetheless. And so I had another case that I took apart, so I pulled the shift collar out of that, and it doesn't have any cracks, so I'm going to use this one. Now, to install the shift collar, you need to shift to neutral, and there are basically 3 positions. So back is high range, middle is neutral, all the way forward is low range. So let's go to the middle neutral position and drop the shift collar through the splines in the holding plate. So pull the shift collar so that the splines on this side are pretty much meshed with the holding plate, and the groove, it's better light here, the groove here on the shift ring should be just a little bit ahead of where the shift fork is toward me. So once you're in that position, then shift into high range, which pushes the fork down, and then the shift collar will go down slightly with it. Then with it in this position, you push the shift collar down as far as it will go. And then you can kind of shimmy it around so that the shift fork engages that front groove. And then that's basically it from there. So you can shift it forward. If you shift it all the way up, it'll drop it, of course, because the gears aren't in. But from low range to neutral, you can see that that will work once all the rest of the gears are in to hold the shift collar in place. So that's that for now. We will move on to the assembling some more of the gear train. Here we have the shift collar hub and the reduction hub. If you'll remember from the last video, these get a bearing in between. These are the old bearings. These are old roller needle bearings. They feel sort of square instead of round, the needles do. So we've got some new ones of those. And for those I went with the KOYO NTA 2840. Alright. There are other options from other companies. The reason I chose these is, most of these all have the same spec and same cost roughly, and these had a higher speed rating. So most of them had 4,000 RPM max speed ratings. These were 6,000. So in the spirit of more is better, than I went with the KOYO bearings. So just like all the other parts, I'd like to soak those in some of the fluid before we install them. I'm going to do that, and I'll be right back. Okay, now we have some bearings soaked with transfer case fluid. I'll go ahead and get those installed. One of the thrust bearings goes here, and then the reduction collar hub goes over the shift collar hub, and that bearing rides between the two. Then next we take our ring gear, which we assembled earlier. Assemble the shift collar hub through from this direction. So then next we have another bearing. It goes around the shift collar hub like this. Then comes the pinion cage lock plate. Then we get another bearing after that. Then next comes the sun gear and main shaft. And actually someone had asked me why there are thrust bearings in this assembly to begin with, and the reason is because of these angular cut gears. So when you're in drive and the sun gear spins in this direction, it puts a net force down this shaft through the planetary gears, the planets in the assembly. And so there's a net force going down this drivetrain, and so that's why there's thrust bearings here. So anyway, next you go ahead and install the sun gear. Let that come all the way down. Then support from the back, lift the whole assembly up, flip it over, and there we are. Just to be sure, it wouldn't hurt to look, make sure that sun gear is all the way back into the ring gear. Then on the back part of the shaft here, we get another bearing, another needle bearing. And then we get the direct drive sleeve. That'll hold that bearing in place once we get it assembled. Just make sure that that goes all the way up against the bearing. Okay, once all that's together, then it's ready to go back into the case. We'll do that by placing the case over this from the top. Tricky part is keeping that shift collar well behaved. I think maybe that's the best chance to get it right, is to keep the fork down, and then of course when you put the case on, we'll have to shimmy this around to get everything to align. Alright, so to make this a little easier, try to align everything here before putting on the case. Okay, so that's come almost all the way through the bearing. It's like something isn't perfectly aligned just yet. The snap ring groove has not come all the way. There we go. Just needed to be pulled through. You can see there we're installed back into the case. We pull the main shaft up a little bit, we can now access the snap ring groove. And before the snap ring, of course, there's the spacer we took out, so don't forget that. Now originally these snap rings were select fit thicknesses from about 0.087 to about 0.105. This one happens to be about 0.09. And the idea for the essentially end play of the shaft should be 0.004 to 0.009 in the end, but we only have the one snap ring to choose from essentially, so it'll be a bit of a judgment call. I may have another one or two, but I don't know what thicknesses those are. So if you pull the shaft all the way forward, it doesn't want to stay there. It's a bit of a pain, but I can go ahead and get the snap ring started and we'll deal with that. There we go, that snapped it in. Okay, next is basically just to seal up the power takeoff cover. I'm going to clean that gasket surface with some solvent. Then in my request to keep things from rusting and just messing around with machine parts and whatnot, I came up with this replacement power takeoff cover. So this is the old steel one. I de-rusted it, but it'll rust again. You can see it's already starting to rust again. I don't like that, so here's a billet aluminum replacement. So we'll get that cleaned up as well and get ready for the gasket. Alright, here's the gasket. So what I typically use for these old cork style gaskets is some old sealant, gasket cinch, gasket sealer. Not sure exactly what it is. It sort of has a consistency of rubber cement, but seems to work really well. I have it all over my engine that doesn't leak, or at least it doesn't leak from where it was sealed with this material. So very simple to use. Basically hit all 4 surfaces with a thin layer. So hit both the metal mating surfaces, both sides of the gasket. Let this sit 5 minutes, minimum 5 minutes. It can also sit up to an hour or 2 hours and be ready to assemble, but it does need a few minutes to outgas the solvent a little bit, so I'll be back in 5 minutes. Okay, now the gasket cinch has had a chance to set up. So the cool thing about it is it dries a little sticky, so if you're doing a gasket on a vertical surface, you can glue it into place so it doesn't fall off. Then I like to replace the steel bolts with stainless steel bolts, just so that much less rust to worry about. And I put a little bit of Loctite silver anti-seize on any stainless fastener so it doesn't gall. And I'm using just a flat washer, an internal tooth lock washer. Okay, now I'll torque those bolts to 20 foot-pounds. Okay, and then one last thing, the oil fill plug, I'll replace that with a stainless steel version and with a very strong magnet, so maybe have a chance to catch any of the metal particles that form from inside the case as it wears. I will seal this with some Teflon tape once I actually install fluid. For now, I'll just store it here. Okay, and then that's it really. Completely rebuilt Quadratrac low range unit. Of course, the final piece is the planetary gears. Just want to test fit these, make sure everything's good. And there we go. See the low range, the planet spin inside the ring. High range, everything spins together. Okay, that's it. Thanks for watching.